Saxon Algebra 1, Lesson 76. Here is my reminder that this week when we're going to do the review problems, you guys are going to go back and recreate for me the rules for exponents chart. Let me see if I can find it quickly and easily. You know what I'm talking about, right? The rules for exponents. Here it is. You're going to create this for me. I'm going to give you these three names in this, and then those will be empty. Look, I can show it to you. I've got it right here. And you're going to fill it in for me. Right? Wait, I didn't have it marked. Oh my gosh. There it is. I'm going to give you this, and you're going to give me this, and you're going to get it exactly perfectly right. I want these lowercase m's and n's. I want it really clear what's a multiplication and what's an add or a minus, right? I want the parentheses on. I want this perfect. And I want you to smile after you finish and lean back and say, I know I got that exactly right. Okay? That's a must do. I'm being really bossy and controlling about that. I know. But it's important. So please memorize it. Okay, we're not going to do anything related to that today. Today, in Lesson 76, we're going to come up with an introduction to a certain kind of word problem that we're going to be fooling around with for, I think into next year. We'll continue to mess with it. The problems look like this. It says, find 3 consecutive integers. So remember, integers are like -3, -2, -1, 0, 1, 2, in either direction, right? No fractions, no decimals. Consecutive means in a row. So we're looking for 3 numbers in a row. Such that the sum of the first and the third is 146. All right, here's the secret. We could say, we need to set up variables for these 3 numbers, right? These 3 consecutive integers that we're supposed to find, we need to set up variables for them. Well, the first temptation is to say, well, let's call the first one X and the second one Y and the third one Z, right? But that's a terrible idea because we have to have one equation for every different letter that we use, and I don't want 3 equations to you. So we're not going to do that. I throw that idea right out the window. What we're going to do is we're going to call the first one N, short for number. Then, because we know that they're in a row, we're going to say that the next one is N plus 1, and the third one is N plus 2. Aha! Now what we've done is we've built a system of variables that will allow us to write just one equation, and we'll be able to solve it because we really only have one variable. And we've just, done a little math here to make those work. So let's try this again. Find 3 consecutive integers such that, okay, here comes the tricky part. The sum of the first and the third is 146. Okay, so the sum of the first and the third. Sum means add. So what we can say is n plus, and we can put this in parentheses if we want, n plus 2 is 146. The sum of the first and the third is 146. All right, now we just solve it. These parentheses aren't doing a darn thing because there's no number out here and there's no negative sign to change things around. So we can just take that off, or better yet, ignore it. And we'll change this to 2n plus 2 equals 146. Okay, now we've got the two friends over. This guy goes home first. Sorry, friend. This guy's staying for dinner. 144. But now finally it's time and he needs to peel himself away and go home. And we get n equals, let's see, I can divide that in half on my head. Half of 14 is 7. Half of 4 is 2. So what we get is a solution that n equals 42. What that tells us is our first number is 72. Our second number, we add 1 to it, so it must be 73. And then our third number, we take the n number and add 2 to it. So this is 74. And those are the right answers, right? Yes. Yay. Okay, setting up the variables using this format is the secret of success in these problems. We have a total of 3. Okay, find 3 consecutive integers such that, okay, I'm going to pause because I know all the details are coming. So I'm going to stop and set up my variables. And it really helps to do this. I know it's a lot of writing, but these are going to get harder, and it's going to be really helpful if you have all of this laid out for yourself ahead of time. Twice the sum of the first 2. Okay, let's write that much. Twice the sum of the first 2, n plus 1. We saw up here, you can put parentheses around if you want, but I don't want to do that because they're already in parentheses. Twice the sum of the first 2 is less than 3 times the third. Okay? 2 times the sum of the first 2 is less than 3 times the third. Here, the parentheses are really important, aren't they? Because I have to multiply that. Okay, now I've written an inequality. I left one word out. I didn't tell you how much less it is because I wanted to write the inequality first. That is the secret to getting these problems right. Write an inequality first. Now we can see, oh, this side is smaller, this side is bigger. We can tell, right? This tells us greater, lesser. So in order to make this thing balance, we're going to have to either subtract over here or add to this side. And the problem will tell us the number. I'll reveal that in just a minute. But before we look at that number, we get our head on straight and go, okay, but what am I going to do with this number? We have a choice. We can add it to this side. That will make this side bigger, and they'll be equal. Or we can subtract it from this side, and that will make this side smaller. I will tell you my secret. I always adjust the right side so that I don't have to rewrite the problem. I've got room here to make the adjustment, okay? So that's my little secret to being efficient. So this tells me that this side is greater, so I'm going to subtract the number. Now I go back to the problem and find it. Twice the sum of the first 2 is 2 less than 3 times the third. So the number I need to subtract is 2. Once I add that part, I can change this to an equal sign, and I don't have to rewrite the whole problem. Do you see what I'm saying? So much easier. This is a lot of subtlety and very careful thinking. And it's very easy to get these problems wrongity wrong, or just be wildly confused. So follow my thinking as best you can. Now we're ready to just do algebra and everything's okay. This we're going to change to 2n. Then we'll distribute and we'll distribute. Ready? 2 times 2n is 4n plus 2 equals 3n plus 6 minus 2. Notice I don't distribute to this because that's outside of the parentheses. Okay, now what I'm going to do is I'm going to subtract the 3n from both sides. And I'm going to subtract the 2 and swim that guy over this way. I could add those as like terms first, but I'm just going to do it in one big crush. This leaves me with n. That goes away. Equals that goes away. And now I have 6 minus 2 minus 2, and that will be 2. Oh. Such a cute number, right? So over here we can go 2, and then we add 1, so this is 3, and then we add 1 more, so this is 4. I like to write my answers by my variables so that it's really clear which one's which. Later, this is going to get more confusing, and we won't just be adding 1, 2. It'll be kookier. So it helps to come back over here, plug in your first value, and then do your addition to make it work. Okay, one more. Find 4 consecutive integers. What? First, second, third, fourth. Please write this chart just the way I show you. The first one will be n. N plus 1, n plus 2. Now you can see that these little stories that we use to write out our equations are going to get more complicated. And if we've got the code all broken down right here, it makes it a lot easier to set up our equation. Here we go. Find 4 consecutive integers such that, the word such at, you know things are going to get real after I say that. 6 times the sum of the first and fourth. Okay, 6 times the sum of the first and the fourth. Is less than, I'm not going to tell you the number of how many less than, is less than 10 times the third. Okay, so when John says first, second, third, or fourth, I refer to my little chart, and it's confusing because like the third doesn't add a 3, the third adds a 2, right? When I hear third, I automatically want to say n plus 3, but that's not right, it's n plus 2. So use this little chart to substitute in as you go. All right, it's less, this is less than again, was the way this was written, so I wrote it properly. Now I stop and get my head straight. How do I want to adjust this? I can add and make this side bigger, or I can subtract on this side and make it smaller. So that's what I'm going to do. The number is 26. So I'm going to subtract 26 from this side. That will make it equal. They aren't always less than. Sometimes they're greater than. And then you have to re-logic out, okay, how do I find balance in the the equation? All right, ready? This is going to become 2n again. This almost always happens. So I'm going to squiggle that out. I'm going to distribute, and then I'll have to distribute here as well. All right, 12n plus 18 equals 10n plus 20 minus 26. Okay, I'm going to do the same thing I did last time. I'm going to swim these all around so that the numbers will all end up over here, and then I'll do all that math at once. So I'm going to bring the n fishy over this way, and then I'm going to swim the plain numbers that way. 2n, goodbye, goodbye. 20 minus 26 is minus 6. And then minus 18 more, that is minus 24. That's a big number. But, and don't let it freak you out. If it's a negative number, it's a negative number. It's fine. We divide and we get n equals negative 12, right? And so I go over here and I fill in my chart. Negative 12. Now, think carefully. We want to go negative 13, negative 14, negative 15. No, we're adding 1. So that means we're climbing the ladder up out of the meadow toward the sun with every step. So it goes to negative 11, negative 10, and then negative 9. Those are the right answers. John spends time in his solutions checking it, plugging these numbers back into the original equation and making sure they're right. That does not impress me. You don't need to do that. Unless John tells you in the instructions to check your answer, that is not necessary. That's just John being a little bit of, what? Overeager, right? He's just being a little bit overeager. Okay. That is the end of lesson 76. Like I said, we're going to be working these problems and putting some new complicating factors on them as we go. So you will see them again and again. I know, you're welcome in advance. Make sure you study that rules for exponents chart, and I will talk to you online Thursday or Friday. Yay, thank you. Goodbye.